Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with 1.5, which is describing angle pair relationships. The essential question is, how are different angle pair relationships classified or measured? We have a warm-up. So we know the big angle, ABC, is 94 degrees, and we're looking for CBD. And keep in mind, you're either going to do angle addition postulate where you add them up to something, or you're going to set them equal if BD is an angle bisector. Think about which one it is and try to give it a try. See how you do. All right, so this one actually, we don't know that BD is an angle bisector, but we do know that the big angle is 94. So that means it's going to add, ABC is going to add up to 94. So we need to add the two smaller angles, which is 3x plus 15. Plus x plus 7 equals 94. Combine like terms, we got 3x and x is 4x. 15 plus 7 is 22. Equals 94. Now, is there any addition or subtraction to take care of here? Yep, we got to subtract 22 from both sides. So we get 4x equals 94 minus 22 is 72. Divide by 4. We get x equals 18. Are we done? What are we looking for? We're looking for CBD. CBD is x plus 7, so measure of angle CBD equals x plus 7, and x equals 18. So for x, we're going to put 18 plus 7. So measure of angle CBD equals 25 degrees. And there we go. All right, moving on. So we're going to talk about different types of angle pair relationships here. We're going to do some drawings too. Hopefully this will help us, okay? So, complementary angles. They add up to 90 degrees. How many degrees? 90. Supplementary angles add up to 180 degrees. How many degrees? 180. Adjacent angles are two angles that share a common side. A common what? Side. Adjacent means next to. So we're going to draw some little angles over here. It's not going to be perfect, but we'll see how we do. So I'm going to draw two angles like this. Let me go a little more narrow here. So we have A and B. So A and B are adjacent angles. They're side by side. Okay? A linear pair are adjacent angles that form a straight angle. What kind of angle? A straight angle. What's a straight angle? How many degrees is that? It's 180 degrees, right? Okay, and a linear pair, it's actually going to be a straight line with an angle next to, like in the middle of it, okay? So it's going to be a straight line. So we have x and y make a straight line. So we can do a linear pair would be x and y, okay? I can't really draw straight lines in here, and I do apologize for that. All right, vertical angles. Two angles that are across the vertex. Across the what? Across the vertex and are congruent. Are what? Are congruent. Let's draw some vertical angles here. So we're going to draw two intersecting lines. So we have R, S, P, and T. So the vertical angles are across the vertex. Let's use different colors here. R and P. Let's go over here. So we have R and P. R and P are vertical angles, and also S and T. So you can see they're across the vertex, they're across the middle part there, and they have to be congruent, okay? They have to be congruent, okay? All right, now for this example, it says we're going to classify the following angles as adjacent, a linear pair, vertical angles, or neither. Let's try a couple of these. Why don't we try, we'll try this one, 2 and 3, and 5 and 8. Okay, we'll do two of these together, and you guys will try a few, okay? All right, so we have angle 2 and angle 3. That's this angle and this angle right here. What do you guys think? Are they adjacent? Are they side by side with a shared side? They are adjacent, but now next one we gotta check is if they're a linear pair. Do they make a straight line? These angles make a straight line or no? They do not. They make like an obtuse angle. So this one's just gonna be an adjacent. These are adjacent angles. Okay, they're side by side, but they don't make a straight line. All right, how about 5 and 8? 5 and 8 looks like they are across the vertex from each other. Are they look like they're congruent? They are. These are actually vertical angles here. They're vertical angles. They're across the vertex, and they make, they basically, like, you can see that they, like, share, like, a PRST over here. They share a common endpoint or vertex, okay? All right, why don't you guys try the rest of these on your own, and we'll check our work in a second. Go ahead and pause the video. All right, 1 and 3. Let's use a different color here. We have 1 and 3. Here's angle 1. Here's angle 3. Are those, okay, they're not sharing a side. They're sharing a vertex, but are they vertical angles or no? They're actually not. If you were to kind of like extend 1, 3 should be up here. These are across the vertex. These are actually not vertical angles. If you said vertical angles, I tricked you, and I do apologize. This is going to be neither. They're not adjacent. They're not linear pair. They're not vertical angles either. How about 4 and 5? 4 and 5 with these ones, they make a straight angle, and I like to go like this and draw a little loop to show that they make a straight line. What are those called? They are adjacent angles, but they're also a linear pair, so we want to say a linear pair is the most specific name for it. And then 4 and 9 are across the vertex from each other. Those are congruent and across the vertex. Those are vertical angles. Okay? All right. If you want to pause the video and try the checkpoint to get even more examples to try, go ahead and do that. All right, so let's find an example of a linear pair, adjacent angles, and vertical angles. All right, so a linear pair needs to make a straight line with 2 angles. Pair means 2. So we need 2 angles that make a straight line. Well, I see that 1 and 2 make a straight line, so I have angle 1 and angle 2. Anyone else, any other ones that work? We also have 2 and 3. Oops, I'll put that up here. Angle 2 and angle 3. Those are the types of linear pairs there. How about adjacent angles? Which ones are side by side? Well, literally, there's like any angles that are side by side. We could do 4 and 5. We could do 1 and 5. Like, actually, we shouldn't do that little loop there. We should do, yeah, like 4 and 5 are next to each other. We could do 1 and 5 are next to each other. We're just gonna put 4 and 5. But if you put any angles that were side by side, that's all, that share a common like ray in the middle, that's all you got to do. And vertical angles, there's actually only one pair of vertical angles here that make that are congruent. Like 2 and 5 are across the vertex, but they're not congruent because you can see that 4 and 5 make up the entire angle 2 here, so that one's not going to work. But angle 1 and angle 3 are the vertical angles here. All right. Kind of tricky. Okay, sounds good. Example 2. Finding complements and supplements. All right, given that angle 1 is a complement of angle 2 and measure of angle 2 equals 57, find measure of angle 1. Okay. What does complement mean? Is that 90 degrees or 180 degrees? That is 90 degrees. So we know that measure of angle 1 plus measure of angle 2 equals 90 degrees. Okay. Now, what else do we know here? Well, we also know that measure of angle 2 equals 57, and we're trying to find measure of angle 1. So I'm just going to call measure of angle 1, I'm going to call that x, that's what we're looking for, plus measure of angle 2, which is 57, equals 90. How do we solve this from here? Subtract 57, so x equals 33, or measure of angle 1 equals 33 degrees. Okay. All right, why don't you guys try checkpoint 2? And we're talking about supplements instead of complements, but it's basically going to be the same thing. Give it a try. All right, supplements add up to 180 degrees. We know measure of angle 4 is this. We're looking for measure of angle 3. So we'll call these x here. So we have measure of angle 3 plus measure of angle 4 equals 180. We know measure of angle 3 is going to be x, what we're looking for. Angle 4 is 41. Equals 180, subtract 41, x equals 139, or measure of angle 3 equals 139 degrees. Okay, all right, next example. Yeah, let's get into this here. All right, a basketball pole forms a pair of supplementary angles with the ground. Find the angles there. Okay, so what does supplementary mean again? It means 180 degrees. So these two angles right here, they add to 180 degrees. So what are we going to do you think we're going to do here? This is kind of like an angle addition postulate here. So what are we going to do to those two angles? Well, we're going to add them up to 180 degrees. So 3x plus 8 plus 4x minus 3 equals 180 degrees. Now we're going to combine like terms and solve. 3x plus 4x is what? 7x. 8 minus 3 is what? Is 5. Equals 180. If you guys want to pause it and solve from here, you can go ahead and do that. I forgot to give you a chance. We're going to keep going here. How do we solve for x now? Minus 5. 7x equals 175. Divide by 7. X equals 25. Are we done? We are not. We got to find measure of angle. We'll start with angle BCA. Oh, he's got a box what we're looking for. Dang it. BCA equals, well, BCA was 3x plus 8. So we're going to plug in 3 times 25, which is x, plus 8. I put 2. Whoops. 3 times 25 plus 8. 3 times 25 equals 75. Plus 8 equals 83. So measure of angle BCA equals 83 degrees. And then the other one, we're looking for measure of angle DCA. It's going to be 4x minus 3, which equals 4 times 25. I think it was 25, yep. Minus 3. It's 100 minus 3. And measure of angle DCA equals 97 degrees. Okay, and do those add up to 180? Looks like they do. Okay, if you want to try checkpoint 3, it's basically the same thing, except we're replacing the angles. This angle we're replacing with 5x plus 1. And this angle we're replacing with 6x plus 3. If you'd like to try the same problem, but with different numbers, give it a try. Okay, same thing here. They add up to 180. They're supplementary. So we have 5x plus 1 plus 6x plus 3 equals 180. Combine like terms, 5x, 6x, 1 and 3. 5x plus 6x is 11x. Plus 1 plus 3 is 4 equals 180. Subtract 4. 11x equals 176. X should be divided by 11. I didn't show all the work on my notes here, but I think x should be equal to, let me just double check my work. Yep, 16. Okay, and if you were to plug those into the equation, you're going to get measure of angle BCA equals 81 degrees. And measure of angle DCA is going to equal 99 degrees. Okay? Alrighty. We have a couple more examples to get through here. So, let's keep moving. Okay, next example. Two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Alright, here's what we're going to do. We're going to draw kind of a linear pair like this, okay? We're going to call the smaller angle x and the bigger angle y. Okay? So, let's say the smaller angle is x. The measure of one angle is 4 times the measure of the other. Okay, which one's bigger, y or x? So y is going to be, how do we say that y is 4 times as big as x? What are we going to write? y equals 4x, right? Does that make sense? If, yeah, so one angle is 4 times as big as the other. If the smaller angle is x, we would have, then we would have y equals 4x. All right, so we have y equals 4x, and we know that this is a linear pair, which means these add up to what? Linear pair is a straight line, which is 180 degrees, so x plus y equals 180, but what do we know about y? Y equals 4x. We can do x plus 4x equals 180. All right, and now we got to combine like terms. X plus 4x is 5x. Equals 180. And now we need to solve for x. We need to divide by 5. And x equals 36. Are we done? We know one angle is, measure of angle 1. We know one angle is 36. We got to find the other angle, though. Well, y is equal to 4x, right? But x is 36. So we have 4 times 36 So we have measured angle 1 is going to equal 36 degrees, what was x, and measured angle 2, which is y, is going to equal 4 times 36, which is 144 degrees, okay? And those make up 180 degrees, so we did it right. Okay? All right, why don't you guys try the second example, the checkpoint on your own. It's the same thing, just a little bit different numbers. Go ahead. All right, so two angles form a linear pair. We have x. We have x and we have y. In this case, one angle is 3 times the measure of the other, so we're going to call y equals 3x. We know x plus y is a linear pair, adds up to 180 degrees, but we know that y equals 3x. And x plus 3x is 4x equals 180. Divide by 4. And we're going to get x equals 45 degrees. So that's one of the angles. And the other angle, if you do 3 times 45, is going to be 135. So measure angle 1 equals 45 degrees. And measured angle 2 equals 135 degrees. All right, last type of example. These last ones are a little tricky, so make sure you stay with me here, okay? All right, so we're looking for, it says find x and y. We got a lot of things happening here, all right? So with these kind of problems, we're going to use vertical angles or linear pairs, okay? We're going to use either of those, but only use angles that have one variable. I'm going to underline one variable. Okay, so what does that mean? What does that mean? Take some time to write that down real quick, okay? All right, so we're looking for x and y. So we have a couple things happening here. We have vertical angles and linear pairs. So for example, these two right here, 3x plus 7 and y plus 75 make a linear pair, don't they? Well, they do, which you could add them up to 180, but the problem is that we have 3x plus 7 and y plus 75. We can only have one variable, only one variable we need to use in order to solve this. We can't have like x and y in the same equation or else it won't solve, okay? So, what are we going to do instead? Which one has only x and only y? Well, these two have only x. These two have only x, so we can do 5x minus 35, and our vertical angles congruent or supplementary? They are congruent, so we're going to do 5x minus 35 equals 3x plus 7. Okay, and the other one we have is y plus 75 and 3y plus 5. Are those vertical angles or linear pair? Those are vertical angles, so we're going to do 3y plus 5 equals y plus 75. Why don't you guys go ahead and solve those from there now and see how you do. All right, we need to solve for x now. We're going to subtract 3x from both sides. We have 2x minus 35 equals 7. Add 35. So we get x equals, that's going to be, or 2x, sorry. 2x equals 42. Divide by 2. We get x equals 21 degrees. And we're just looking for x. Actually, that's fine. We're looking for x. Then for y, we can just subtract y from both sides over here. We get 2y plus 5 equals 75 minus 5. 2y equals 70. Divide by 2. And y equals 35 degrees. Okay? So that's kind of how we do it. So either vertical angles or linear pairs, but you want to make sure that the angles you choose have only one variable, either both x or both y. Why don't you guys, checkpoint 5 might be a little bit trickier, but see if you can figure it out. You may have to find one pair first and then use what you figure out to find the other one. See if you can figure it out though. You pause the video. Okay, sounds good. So we have this over here, 5x and 12x minus 41 and 5y. Well, we have x's. The x's are, we only have x's in two angles, and we have y in another angle. So we're going to use these two angles because those are the only ones that both have x. What kind of angles are those? Are those linear pairs or vertical angles? They're a linear pair, so we're going to add them up to 180. So 5x plus 12x minus 41 equals 180. What are the like terms here? 5x and 12x is going to be 17x. minus 41 equals 180. Add 41. 17x equals 180 plus 41 is 221. Divide by 17. X equals 13 degrees. Okay, so that's one of the angles, but now we have a problem here. The problem is that we have like we want to use x and y here, but we have to solve for y, but we have to be a little bit tricky here. Okay, so we can either use 5x and 5y and do linear pair, or else we could do 12x minus 41 and 5y. Let's do these two because I like setting things equal. So we're gonna do 5y equals 12x minus 41, right? Because those are vertical angles. But we know that x is 13, so I can plug in 12 times what? 13 minus 41. Okay? So 5y equals 12 times 13 is 156 minus 41. 5y equals 115. Give me one sec. Okay, so we did that. Now we divide by 5. And y is going to be equal to 23 degrees. And now we have our answer. So sometimes you may need to kind of work your way around the graph or around the diagram to kind of get to a different point there. But that should be our answer for that one. Okay, that's just all we have for this lesson, I believe. Yep, we're good. Thanks for watching. Have a great day, and we will talk soon.